Here we have AP calculus AB problem. Okay, let's go with the information. Use the table of values to find lower and upper estimates of integral 0 to 10 f of x dx. Assume that f is a decreasing function. Okay, so to find the lower estimate and upper estimate, so what we have to do is we have to be knowing two things in advance. One is the number of subintervals and the width of each subinterval. So when you look at the integration over here, the lower limit is 0, the upper limit is 10. So in the given table also, the starting value of x is 0, the ending value of x is 10. Okay, now let me draw a number line over here. So the starting value of x is 0 and the ending value of x is 10. And so the next in the table, the next value of after 0, the next value of x is 2. So let me mark 2 over here. So the next value is 4 and the next value is 6 and the next value is 8. So I just marked all these values of x on the number line. So now we can count the number of subintervals over here. This is the first subinterval, second subinterval, third subinterval, fourth subinterval and fifth subinterval. So for the given lower limit and upper limit, and also from the values we have in the table, so we get 5 subintervals, and the width of each subinterval is just 2 units. Okay, now so we have to consider an important information over here, that is f is a decreasing function. So when f is a decreasing function, then we can find lower estimate by doing right endpoint approximation of Riemann sums. So how do you have to calculate the right endpoint approximation of Riemann sum? So for that, they have a formula. Let me write the stuff over here. That is a lower estimate is equal to, let me write the stuff over here. So to find lower estimate, we have to do right endpoint approximation of Riemann sum, because f is a decreasing function. In case f is an increasing function, so then to get lower estimate, we have to do left endpoint approximation of Riemann sum. But here it's a decreasing function, so we have to do right endpoint approximation of Riemann sum to get lower estimate. So the formula is going to be, it's actually this general formula, that is delta x summation times summation f of xi. It's a general formula for both lower estimate and upper estimate. So here this delta x represents the width of each subinterval. So clearly the width of each subinterval is just 2 units. We can plug in 2 for this. And now we have to plug in the values for x over here, and all the function values must be added, because here we have summation. Okay, so as I said already, f is a decreasing function. We have to do right endpoint approximation of Riemann sum to get lower sums. So in this number line, so in this 5 subintervals, we have to consider the right endpoint. For the first subinterval, the right endpoint is 2. For the second subinterval, the right endpoint is 4. The third one, the right endpoint is 6. And the fourth subinterval, 8 is the right endpoint. And for the fifth subinterval, 10 is the right endpoint. So now first let me take the right endpoint of the first subinterval, that is 2. So I have to plug in 2 for x over here. Then I'm getting f of 2. Then for the second subinterval, the right endpoint is 4. Then we have to plug in 4 for x over here. Then f of 6, positive f of 8, positive f of 10. Here 2 times. So the value of f of 2 is 22. That is the value of the function when x equals to 2. So we can plug in 22 for f of 2, and f of 4 is 14. And f of 6 is negative 3, and f of 8 is negative 24, and f of 10 is negative 36. So then we get 2 times, when I combine the 2 positive values, 22 and positive 14, I'm getting positive 36. So when I combine the 3 negative values, negative 3, negative 24 and negative 36, I'm getting negative 63. So now 2 times, when I simplify this 36 and negative 63, I'm getting negative 27. So when I multiply 2 and negative 27, I'm getting negative 54. So the lower estimate is negative 54. Okay, now let me erase the stuff over here and do the upper estimate. Okay, now let's find upper estimate. Let me write the stuff over here, upper estimate. So for this one also we have the same formula, that is delta x times summation of f of xi. Okay, so the delta x, the width of each subinterval, that is 2 times. So here, since we do upper estimate, and also again we have to notice an important information, that is f is a decreasing function. When f is a decreasing function, to find upper estimate, what we have to do is we have to do left hand point approximation of Riemann sum. That is in each subinterval over here, we have to consider the left hand point. So for the first subinterval, the left hand point is 0. For the second subinterval, the left hand point is 2. And for the third one, it's 4. For the fourth one, it's 6. And for the fifth one, it's 8. So now I have to plug in these 5 values of x over here in f of x, and I have to add them all because we have summation over here. Then we get f of 0, positive f of 2, positive f of 4, positive f of 6, positive f of 8. Okay, now 2 times f of 0. What is the value of f of 0? So we can get the value of f of 0 from the table over here. That is the value of f of x when x equals to 0. That is 34. And f of 2 is 22. And f of 4 from the table is 14. And the value of f of 6 from the table is negative 3. And the value of f of 8 from the table is negative 24. Okay, now 2 times. Now we have to combine the positive values we have over here. So when I add 34 and 22, I am getting 56. 56 positive, 14 is 70. Negative. So when I combine these two values, so negative 3 and negative 25, I'm getting negative 27. Okay, 2 times. When I subtract 27 from 70, I am getting 43. 2 times 43 is 86. So the upper estimate is positive 86.